Well, welcome everyone. I'm glad you've joined me today for this Data Summary and Analysis in JMP webinar. I want to cover a lot of things today, so I'm going to jump in very quickly. The first thing I want to talk about is a few resources for learning JMP. This webinar is going to show you a lot of things. If you'd like to explore these topics or other topics, there are some great resources that I'm going to point out for you to learn more. And then I'm also going to give you a quick preview of what we'll cover. We're going to talk about some simple data summary things like tables, creating tables like this household income for regions of the United States, the Midwest, the Northeast, the South, the West. So I'll show you how to make tables. I'll show you how to make some simple typical graphics in JMP, like this box plot split on household income split by region. We'll look at how to create regression lines simply and quickly. So this is looking at IQ as a predictor of household income and split by region. We'll look at making geographic maps to show features of the data. Here we have vegetable consumption as a proportion across the U.S. And we'll look at some analysis techniques, such as regression, fitting a linear regression line, looking at the diagnostic plots very quickly from that platform. We'll look at a one-way ANOVA, and we'll compare groups. So this is again household income split by the 4 regions, and we'll look at what this output means. We'll look at how to get means and standard deviations for those groups, how to get comparisons between the differences. We'll look at a contingency analysis with this mosaic plot, looking at a categorical factor on a categorical factor. So this is passenger class in the Titanic data. So we have 1,300 passengers on the Titanic, and we can predict their survival based on their passenger class. So we'll look at a contingency analysis. We'll look at a logistic regression. Again, using the Titanic data, we'll predict survival based on a continuous variable age. So we'll see from this plot that younger people had a higher chance of survival because this distance here in the blue is much larger. So younger people had a higher chance of survival. So we'll see a logistic regression. And then we'll extend these to models that have multiple predictors or multiple responses. So we'll start looking at a logistic regression that has multiple predictor variables. So not just passenger class, but also the sex of the passenger and the age of the passenger. We'll look at which of these effects are most predictive. We'll look at the prediction profiler to see a picture of what that model actually is telling us, what the predicted survival probability is based on different categories or different values for the continuous variable. We'll do the same thing for a typical linear regression with multiple predictors. So in this case, we could predict household income based on a number of factors such as IQ, population of the state, 8th grade math scores in the state. Again, we can look at the prediction profiler to see how as we change values of those predictors, that's going to change our response. And then we'll jump over into some multivariate analyses. We'll look at correlations, getting correlations on a bunch of different continuous measurements together and looking at a scatter plot matrix. We can get a 3D scatter plot that we can rotate in space. We'll cluster some variables, so we'll look at birth and death rates across the world and cluster countries based on birth and death rates. So here I've chosen 4 clusters, and then I've shown those clusters on a map. And then we'll also look at some summary of unstructured text, creating a word cloud, for example, from unstructured text data. So that's what we're going to cover today. And I'll start by pointing out those resources that are really valuable if you are intrigued by something you see today and you want to know more about it. One place to go is our jmp.com/teach website. This is our academic webpage. And since my internet seems really slow right now, I'll just hope that this loads, and I'll let you know that there are a number of resources available on this webpage. One of the resources I really want to direct your attention to is our learning library. So here toward the bottom of the page, we have a bunch of resources. The learning library here has one-page guides, how-to videos, and tutorials. So these are just, if you want to know how to get a correlation out of JMP, this is where you want to go to search for a correlation, and you'll find a one-page guide that tells you exactly how to get a correlation out of JMP, and then has a 2 to 3 minute video showing you that same thing. So if you want really quick, direct to the point learning tools, the learning library is a great resource. Also, the academic webinar library is the other resource I'd like to point you to today. if you're learning JMP, all of these tools are wonderful resources. If you're teaching JMP, the case study library is some great examples to use in courses. If you're teaching JMP, the course material library is a great place to go. But if you're learning JMP, the learning library is a great place to get started. And the academic webinar library, where recordings of webinars like this one that you're on right now get posted here. And so you can go back and watch this webinar again, and you can also go back and watch any of our other academic webinar series. We post the recordings here. And if you'd like to register for other academic webinars, you can click here on the live academic webinars to get a page to register for those. And then I also want to mention that the JMP help has a ton of resources in it. So when I'm in JMP, my menu bar at the top has help at the end. The JMP help, if I click on this JMP help, I'm going to have the searchable JMP help. So I can look for how to get a correlation, for example. And so all of the documentation is here, and I can search in the documentation. Also from the help menu, I can go directly to the documentation. If I just want to read a little bit or find some examples about specific topics, I can find, for example, basic analyses. These books are JMP's documentation. So there's lots of examples and lots of details about what's happening in the platforms here. The JMP user community is the third resource I want to direct you to. So jmp.com/teach, lots of resources. The JMP help, lots of resources, and also our community.jmp.com. I can get to it from the help menu by clicking on this link. I can also go directly to community.jmp.com. And the JMP user community is a place where you can post questions, you can look for other people's questions and answers that have been posted, and you can explore add-ins that users are uploading that might be solutions for particular questions that you have. All right, now let's get into JMP. I'm going to open this JMP data table that's US demographics. So I already showed you some output from this, and we're going to create that output now. This data set has one row for each state in the US. I can see down here that there are 50 rows. So this is all the states. The District of Columbia is not included in this data. And then each variable, each column variable, is the average for that state. So the average household income for Alabama is $38,160. If I double click on this column, I can see some extra information about it. For example, I can see that there's a column property that's called a note, and this tells me this is mean household income in dollars. Now, if you've never seen JMP before, I'm going to try to point out the features you'd need, but if you have used JMP before and you're ready to start becoming more efficient with JMP, I also want to point out some features for you that are maybe sort of a second level. So if you're brand new to JMP, it's really easy to get started. It's very simple for you to go to Analyze, click on Distribution or Fit Y by X or Tabulate, Text Explorer, Fit Model. We'll talk about all of these today, and just get an analysis right away. So jumping into JMP is very quick, but becoming really efficient in JMP is sort of a next level. So I'm going to show you a few of those features today. And one of those is when I double click and get this column name, column information, these column properties is a place where I can add a lot of information about this column, including things like I can label the values, I can value order. So if this was categorical and I wanted the order of these to show up in a certain order, so if I'm looking at region, for example, so let's click on region, I could add a value ordering where I could change the order that these appear in plots. So one of these second level things you can do in JMP is just by double clicking on a column, on the column name, you can find these column properties and you can add aspects of these column properties like labels or value ordering or a note to the column. So we can see here vegetable consumption, for example, is the percentage of residents who eat at least 5 servings of fruits and vegetables per day. I can see that 8th grade math doesn't have a note associated with it. And another feature that I can see when I'm double clicking on these, if I click on household income again, I can see that it says the data type is numeric, the modeling type is continuous. This is very important for how JMP deals with this. So this is clearly numeric data. These are numbers in this column, and JMP is treating this as continuous. Another way you can tell that is on the side in this columns panel, I can see this little blue triangle, and that indicates that this is being treated as continuous data. Region, on the other hand, is character data, and it's being treated as nominal. And I can see that on the side with these little red bars. This is really important in JMP because the JMP is context-based. So when you launch a platform, for example, I'll go to Analyze and Distribution, and I'll ask for some of these variables. I'm going to get different options based on the modeling type over here. So for region, I'll get some different output options than I'm going to get for these blue triangle, household income and IQ. So I'll show you this right now. I'm going to try to click off of Alabama so that it's not, oops, not highlighted. So here I see for household income, I have a distribution for the household income data, for IQ, a distribution for the IQ data, and for region, I have each region, I see the counts in each region. I can use these red triangles, so this is a second tip about JMP. Red triangles and right-clicking are how you find lots of options in JMP. So you want to right-click on lots of things, and you want to always click the red triangles to find the options. So here in this context, for household income, if I click on the red triangle, I'm going to see options like testing a mean, testing a standard deviation. If I test the mean, for example, I can say that I want to hypothesize that the average household income of the averages for the states, so the average of averages, this is a strange one. Let's say I want to test that it's 50,000. I can enter that here. I can ask it to do a t-test because I don't know the standard deviation. I can also get a non-parametric option here. And so here I see the output immediately. So the red triangles are a progressive interface that lets you find options that are relevant to the context you're in. I'll see different options from the red triangle for region because region is categorical and not continuous. So instead of testing a mean, I'll see test probabilities. And I'll see a mosaic plot and plotting options that make sense for categories or something that has frequencies. So one other thing I want to show you while we're in distribution, from the red triangle for a continuous variable, this is where I can test whether a normal distribution or another distribution fits my data well. I can find this under continuous fit. And if I wanted to test against all of these distributions, I can click all, and I get this output that shows me ranked in order of best fit to least fit, least best fit. Worst fit, I guess is the word I'm looking for. I can see that log normal is the best fitting distribution according to having the smallest -2 log likelihood and the smallest corrected AIC, which is penalized for the number of parameters that are in the model. And then I can see, because there's a check mark next to this, it shows me the parameter estimates for that fitted log normal. It shows me the shape, the scale parameter and the shape parameter. If I wanted to also see what this fit would look like if it were a normal distribution, I can click next to normal and I can see here's the mean is estimated at 10.7 and the standard deviation at 0.15. And I can see those curves superimposed on the data here. Another feature of the red triangles, this top red triangle will let me do something like stacking this if I wanted to get the orientation different. And so from distribution, we have the opportunity to explore univariate distributions for single variables, but we also, because JMP is dynamically linked, you can see when I click on one of these bars, one of these regions, so I've clicked on the Midwest, I can see the distribution of the Midwest data in all of my other open output. So the dynamic linkage allows me to use this platform distribution, which is technically a univariate platform. I'm looking at one variable at a time, but I can also use this platform to explore relationships between variables because of this dynamic linkage. Okay, so we've got a lot of ground to cover today, so I'm going to move kind of quickly. So we talked a little bit about the distribution platform and the dynamic linkage, about the red triangles, always using these red triangles. You'll see this little red triangle is up here by the column headings, so it gives me some options that have to do with columns. Columns viewer is another option I'd like us to look at for summarizing data. When I open a data spreadsheet and I want to know something about what's going on in my data, the two places I often go, right away our columns viewer and the analyze distribution like we just saw. So I can see some columns options from this red triangle here. I see columns options from this red triangle here. You'll notice these are the same options. JMP is trying to present the reasonable options wherever they'll be reasonable. So I can find column options here, I can find column options here. I can also find column options up here in this columns menu. So if I go to columns viewer, and I can select maybe all of my columns right now, I'm going to click show summary. And here I just see a very simple summary of what's going on in my data. So if I have a lot of columns, so when we use distribution, I put 3 variables into the distribution platform. I could have put all of them in, but because I'm getting a lot of output, it's harder to pan through many variables at the same time. So sometimes, especially if I have a lot of columns in my data set, I'll start here with columns viewer so that I can just get some high level information like how many data points, how many rows are included in each of these variables, how many missing. And so right away I can see that physical activity has 1 value missing. Only 49 states have reported the physical activity value. I can see that I get slightly different information for state and region because those are categorical than I do for the rest of the data. I can look at mins and maxes, mean, standard deviation. Again, I can use this red triangle to find more options, like I can even turn this into a data table. And if I find a variable I'd like to explore more, like maybe I'd like to look at physical activity further, I can then click on the distribution button here to launch this distribution platform. So instead of having to go back up to analyze distribution and select physical activity, I can immediately launch it right here and look at the physical activity. Okay, so let's make a table. A next step in exploring data might be that we want to make a table of summarizing some aspects of this data. So here we're going to go to Analyze and to Tabulate. Tabulate is the platform that allows you to drag and drop column names and features, statistics about those columns, into these zones to create a table. So in this case, let's say I want to describe household income for the various states. So if I drag household income, you can see little blue zones sort of get highlighted as I'm hovering over them. I want to drop here in this zone for the columns. As soon as I dropped, the zones sort of seem like they disappeared. They still exist. As soon as I try to drag something else, those zones will still exist. So right now I've got household income, and by default, JMP selected to show me the sum of all of the household income averages for all the states. If I want to change this value, I could drag another value on top of it. So here's the mean of the state means. If I wanted to split this out by state, I could drag state into this zone. So see that there's a little blue highlighting around that box as I hover. And now this mean household income for each state is actually just the observation. If you remember these data, we only have 1 household income per state. This is the state average. So having the mean here, because I have only 1 observation, it's really just the observation. To remind myself of this, I could show myself how many samples I have for each state. So I could drag n in here also. I could put it on top of mean to replace mean, or I could put it before or after mean in order to add that information as well. So here I'm seeing that here's the mean for Alabama, but there's only 1 observation. I could throw other variables in there as well. I could throw in the standard deviation instead, which makes no sense when I have a sample size of 1. So let's, instead of looking by state, let's look by region. So I can drag region in to this rows section. Again, I can put it before state in order to group the states within regions, or I can drag it after state in order to have the state come first and then the region. Or if I just want region over here and I want to get rid of state, I could have put region on top of state. Or if I'm unhappy with something and I want to take it off, I can also drag it off. This is one of my favorite things. Pay close attention right now because something really fun happened. So as soon as I drag this off, I get this fun little poof. So here I now have the regions, the Midwest, the Northeast, the South, and the West. I have the means, and now I have standard deviations. Let's drag n in again to see what the sample size was. So I see I have 13 states in the Midwest, 11 in the Northeast, 13 in the South, 13 in the West. When I'm happy with my table, I can click Done. And now I'm going to point out a couple things about these tools at the top. Most of the time I'm using the pointer tool, but when I want to select something, I use this fat plus sign, which is the selection tool, in order to highlight what I want to select. And now I can copy and paste this out of JMP and into something like a Word document. So I could Control-C, Control-V into the Word document. Or I can go to File and Export. And I can export this image as an image file. So I can choose a different image file type. I can send it out as interactive HTML with data, which is a great tip if you're using a graph and you want someone to be able to interact with that graph, like still be able to click on the histogram bars. Or I could send it directly into PowerPoint and it will open this figure in PowerPoint. And I can also use the red triangle to save the script to the data table if I want to be able to repeat this table instantly. So if I click the red triangle at the top of anything I do in JMP, anything, the table, a graph, an analysis, anything I do in JMP, if I go to the top red triangle and I choose Save Script to Data Table, and let's call this My New Table. Now back in the data table, I have a little green play button and the words My New Table. When I reopen this data set, if I save this in the data set and I reopen the data set, I can now just click that play button to get back to exactly what I've created before. So this is another great way to save results, is to just anchor them right back into your data table. So the next time you open the data, you have the regression line you built and or the regression model that you built and the tables that you've created. So there's lots of ways to save out data. Okay, so we made a table. Now let's look at some plotting options at some graphs. So we'll spend a bit of time in Analyze today. We talked about distribution. We're going to go to Fit Y by X in just a minute, which is looking at bivariate relationships, 1x, 1y. We talked about Tabulate to make tables. We'll go to Text Explorer later to look at making word clouds and some text summary. We'll spend a little bit of time in Fit Model, which is sort of the big version of Fit Y by X. Fit Model lets you put multiple X's or multiple Y's into your model. And I'll hit a couple little tiny topics down here in these more advanced models. But let's also go over to Graph and to Graph Builder, because Graph Builder is the graph version of that Tabulate. Again, we have drag and drop zones. So here I could, for example, look at household income as my response. I could divide this by region. So here's the household incomes for the various regions. I could use this ribbon at the top to look at different plotting options. So I could pull these bars on if I just want to see what's the average household income. I get more options about the bars on the side if I want to change things about the bar styles. I could connect the means for the Midwest to the Northeast to the South to the West. I could put the connecting the means on the plot at the same time as the bars by dragging the bars on top of the, so I have both of these highlighted in the ribbon. I could drag box plots on. I could drag the points back on so I can see the points in each plot. And then again, when I'm happy with my plot, when I've got the plot that I'm satisfied with and I am ready to print this, I can click Done. And again, I can use the selection tool to select my plot. I can file export to save it as an image file or to save it out in another format, or I can just copy and paste it out. And let's look at just a couple more things in Graph Builder. So we looked at a box plot. What if we had continuous versus continuous, like maybe looking at household income predicted by IQ? I can put a best fit line on this. For the line of fit, again, I have more options. So I can do things like so I have the confidence band shaded in here, the confidence region for this line, but I could also add in the prediction band. I could add in the equation onto the plot. I could add in the R² onto the plot. And then I could look at splitting this out by region. So again, I have these drop zones. I can drag anywhere I want. So far I've just been using the X and Y, but if I pull region into group X, now I have a plot, a regression equation and plot for each of the 4 regions. Or if I drag this into group Y, again, I have the plot for the 4 regions. Or I can wrap and put the 4 regions in corners, or I can overlay and put them right on top of each other. This is really busy and I would not recommend this graph, but if this is what I want as my final graph, I then can click done, and again I have options from the red triangle, or I can use the selection tool to save it, I can export it, but I can also look at some of these other options from the red triangle, like the local data filter. The local data filter, always available in the red triangle, allows me to filter out this plot by some other variable. So if I've put all 4 regions in here, but maybe I want to quickly make this plot with only 2 of the regions. So if I filter by region, so I'm using the local data filter, which I found from the red triangle, and then local data filter. If I use region and add it as a filter, I can now select, let's just look at the Midwest, or let's just look at the Northeast, let's just look at the South, just look at the West. Or I can select multiples. And so I can quickly filter through versions of my data where I'm excluding some data and including other data using this local data filter. All right, and one last graph to show you from Graph Builder. So one last way to summarize data. If you have a column in your data set like state or country name, or if you have latitude and longitude, you can easily make maps in geographic maps in JMP. So in this case, because I have a column that has state names, JMP has a map shape file that recognizes state names. Country names, this is also true. County FIPS codes will work as well. So if I drag this column into the map shape, I now see a map of the US. And if I want to look at household income across, if I want to look at household income as the color, or if I want to look at IQ across this map, or the one I showed you at the very beginning was vegetable consumption. So if I use vegetable consumption, and then maybe I want to change the color scheme on my map, so maybe I'm going to choose a different color scheme. So I double-clicked on the colors here. I'll choose color theme here, and I think what I showed you at the beginning was green, because that seemed to make sense to me for vegetables. It seems like very dark green would be a lot of vegetable consumption. So much spinach in those states. And very white would be not very much. So I chose this as my coloring scheme. So I can see that California, Vermont are pretty high on vegetable consumption. And again, when I'm done, I click done. I can use the fat plus sign, or I can use file export to take this plot out. All right, let's look at fit Y by X now and start looking at some analysis methods like regression, ANOVA, logistic regression. And chi-squared contingency tables. So all of these will be available from this same platform. So distribution is univariate statistics. Fit Y by X is anything where you have one X predicting one Y. So if I wanted, for example, to take the percentage of high school graduates and see if that predicts the vegetable, well, maybe I'll use alcohol consumption. No, I think all of these are percents. Maybe the 8th grade math scores predicting high school graduates. That's a good idea. All right, so let's look at 8th grade math scores predicting high school graduates. Oh, this is also still percent. So I was trying to avoid in this example using something that comes out in a percentage, but this still works. And there does seem to be a trend. So just looking at the plot, I see 8th grade math seems to predict the percent of high school graduates in the state. I use the red triangle to get additional options. like actually fitting the regression line. Fit mean will just fit a line across the middle of the plot for the mean of the response. Fit line will fit a regression line, so that's how I get a linear fit. I see the line in the plot. Again, the red triangle gives me lots more options. So I can put on, for example, I can shade the confidence interval for the mean. I can shade the confidence interval for an individual prediction. I can ask for saving the predictive values back to my data table, saving the residuals back to my data table. I can ask to plot the residuals, so I can quickly see the diagnostic plots to determine whether this regression is a good idea. Am I fitting these data well? Do I have a trend that I'm not capturing? I can also use the top triangle to fit another line at the same time. So maybe a polynomial fit. I could fit a quadratic or a cubic, quartic. I can use fit special to do a transformation right here in place. Instead of going back to my data table and making the transformed values right here, I can do a Y transformation and an X transformation, or just one or the other. I can do these with a centered polynomial. I can constrain the intercept or constrain the slope to a certain value, so I can fit a specific line to these data. If I wanted to, see, our line here was high school graduates equals minus 3.4 plus 0.32 times 8th grade math. If I wanted to constrain the intercept to be 0 actually might make sense here. I can say, click that and say OK, and so now I'll see the line, this green line is now the linear fit where I constrained the intercept to be 0. So that actually is very similar. So I have a lot of options here from the red triangle. I can fit a spline to this as well. But let's look at an ANOVA example. So same platform, fit Y by X. This time I'll use maybe 8th grade math as the response, and I'll use the region as the predictor. So you can see this little picture down here is telling us what's going to happen. If I have a continuous predictor, continuous response, I'll get this regression type situation. Now that I have a categorical predictor, continuous response, I'll get this one-way ANOVA type situation. So I'll say OK. Here the red triangle is where I get more options. So first I see a plot showing me the data for 8th grade math for Midwest, for Northeast, for South, and for West. Now I click on the red triangle and I can do the actual ANOVA analysis by clicking on means ANOVA. This shows me here's the R squared, here's the p-value for the overall ANOVA. Here, using a pooled estimate of the error variance, are the standard errors for the groups. They're the same for all the groups except the Northeast. And that's because they're based on the pooled estimate, and the Northeast is only different because it's got a different sample size. So these standard errors are based on the pooled estimate. I can also get the means and standard deviations for each group by just clicking means and standard deviation. So here's the specific standard deviations for each group and the means. And then I probably, when I'm doing an ANOVA, want to compare these groups to each other. So that's usually the result of an ANOVA that I'm interested in. So to do that, I go to compare means, or to non-parametric if I want to do a non-parametric comparison of means. Anywhere that there's a non-parametric option that's available, it's going to be in the same spot as the parametric option. So JMP is always in the context going to give you all the options that make sense in that context. So the non-parametrics are right here with the parametrics. So I might want to compare all the pairs to each other using the Tukey on a significant difference. If you've never seen this circles report before, if this is brand new to you, and you want to know more about this is true about this topic and any other topic in JMP. When you get output and you don't know what it means, you can use this question mark in the tools bar and hover it over the thing you have a question about. And it's going to open the documentation to that particular context and tell you, okay, here's what's going on in the compare means. And then it'll give you an example to show. So what's happening here is if I click on one of these circles, it's going to bold it and turn it red. So the south corresponds to this bottom circle. The middle of this line corresponds to the middle of the circle. And any other circles that turn red are not significantly different than the one I've clicked on. So south is not significantly different than west, but it is significantly different than northeast and midwest because they're a different color. So that's how you can use the circles, but if you just want a straightforward piece of output, you also get 3 more ways of interpreting the means comparisons down here. So here's the means comparison. Here's the threshold matrix, where positive values show pairs of means that are significantly different. So you look for positive values in here and then find those pairs are significantly different. The connecting letters report, where levels not connected by the same letter are significantly different. Or the easiest one to read, which is the ordered differences report, which shows you the p-value on the far right. It puts an asterisk by it and changes the color if it's significant at the 0.05 or 0.01 or 0.001 level. So here we see that the 2 significant differences from these groups are the Midwest versus South and the Northeast versus South. So again, lots of information here, so many options hidden in this red triangle. But if there's something you don't understand or you have a question about, you can use that question mark here and hover it over the part of the output you have a question about, and it's going to open the JMP documentation for that. All right, let's open this Titanic passengers data set to look at a couple more analyses from fit y by x, which is our logistic regression and chi-squared analysis. So here, if I go to analyze fit y by x, now I'm going to look at survival from the Titanic. So this data set has 1,309 passengers included in it, and we know whether they survived or not, and we know some features about those people. So if I use survival as what I want to predict, and I can use passenger class to predict survival, and this is going to give me categorical predictor, categorical response. It'll give me a contingency chi-squared type of analysis. Or if I use a continuous predictor, like age, that's going to give me a logistic regression type situation. I've put 2 x variables in this platform. Remember that fit y by x is 1x, 1y. So I'm not going to get a model with both of these terms in it. I'm going to get 2 totally separate models, one with age predicting survival, one with passenger class predicting survival. So I'll click OK. Here I get that chi-squared contingency analysis of survival based on passenger class. Here I get the logistic regression of survival based on age. So again, we use the red triangles to get lots of extra information. I can get exact tests. I can get a Cockridge-Armitage trend test. I can use this red triangle to get different output in the contingency table. So if I want the expected counts or the deviation. Here I see the chi-squared tests, the likelihood ratio and the Pearson chi-squared tests that are telling me, yes, there's definitely a difference. And what we see in this mosaic plot, the width of these bars, so passenger class 1, the width of this bar is the proportionate amount of data that were passenger class 1. So we can see 3 is very wide. That's because most of the passengers were passenger class 3. Passenger class 1 is next, and 2 are the fewest passengers. Likewise, on the survival axis, the height of these lines has to do with how many passengers in that class survived. So in passenger class 1, you have a lot of blue, so a high chance of survival for passenger class 1, less so for passenger class 2, and even less for passenger class 3. In the logistic fit, what we're seeing again is it's the space of how much blue compared to how much red. Remember, blue in this case is yes, survived, and red is no, did not survive. So here we see that younger ages have a wider yes, so a higher chance of survival if you're young than when you're older. Okay, so now let's jump into fit model to look at some of those same types of models, a logistic regression and a typical linear regression in the fit model platform, but using more x's. So fit y by x is fantastic and there's lots available there, but when you have more than one x or more than one y, you're going to move into fit model. So that was in analyze, we talked about distribution for univariate, fit y by x for these 1x, 1y, tabulate for making tables, now fit model for bigger models with more than 1x, more than 1y. There's also a lot of other stuff hidden here in fit model. Fit model is a very wide platform. There's a lot, and very deep platform. There's a lot that you can find from this same platform. So you can, we'll start by looking at predicting survival with maybe passenger class, sex, and age. So I'll use 3 x variables. I can drag them into this box. This big box here is now the X box, or I can click the Add button to get them into this box. But I specifically want not just the main effects, but the interactions between these effects. So I'm going to use this macros button, and I'm going to click full factorial. And it's going to put the main effects for passenger class, sex, and age, as well as all the two-way and the three-way interaction into this X box, the model effect box. It's chosen a personality called nominal logistic, and this option up here, I'm going to use this default. I want nominal logistic right now, but I'll click on this to show you that there are many other things I can get here as well, and some of them are grayed out because my Y variable is not amenable to these particular types of analyses because I have something categorical. But there's a lot here. So here, right now, I'm going to do a nominal logistic regression. I'm going to have my target level be 1, which means that I'm predicting survival instead of non-survival. I'll click Run. First, I see just general information about passenger class was a pretty highly significant term. Sex was very significant. Passenger class by sex interaction is also very significant. I can see more information about the model. And something I really want to draw your attention to here, from the red triangle, in Fit Model, one of the best things about using Fit Model is this profiler. So you can usually find the profiler either listed as profiler or as effect profiler in the Fit Model output under the red triangle. So profiler allows you to see visually what your model means. So I'll make this a little bit bigger. Notice that with any plot in JMP, any plot at all, if I hover my mouse down at the corner till I get this little sideways arrow, I can resize the graph automatically. And here, this is really tiny on the side, but this says survived, yes, 0.96, and up at the top, no, 0.04. That's telling me that for passenger class 1, which is selected here, and you can see the red crosshairs, for female, and for age 29.881, the chance of survival is 96%. If I drag this and switch something, so still female, still 29.881 years of age, but now passenger class 2, now I'm down to an 89.5% chance of survival. Again, holding everything else constant, but switching to passenger class 3, I'm down to a 44% chance of survival. Likewise, I can swap between female and male to see how these probabilities are different for a male. And I can see visually the effect of an interaction. Passenger class and sex has an interaction. And I can see that by noticing when I'm in female, here's the shape of the trend line. It's high, still pretty high, really big drop. For male, it's as high as possible, big drop, a little bit higher. So I have a different shape of the trend line for males versus for females, and that's because I have an interaction, a significant interaction effect. For the age, for the continuous, I can also change this by just clicking in this box to see the effect of a different age. So the profiler is incredibly valuable. We'll look at that again really quickly with one more example. Let's go back to the US demographics. I'm going to reopen it. And let's look at, again, Fit Model. This time, let's predict household income by several other variables. So maybe IQ, population, and 8th grade math. Again, I'll do a full factorial. And now my personality by default is standard least squares. So this is a standard least squares regression. I could choose other options as well. For example, if I had random effects in my model, I could select the mixed model personality and add random effects into this box, or if I had a repeated structure and I wanted to specify the covariant structure, I could put that here. So mixed models are available here from Fit Model. ANOVA is available here, partial least squares. The generalized regression platform is a great platform. This allows you to change the distribution of your response. So if you have a zero inflated binomial, for example, or zero inflated Poisson, or if you want to use a beta as your distribution for the response, you can change that here. You can have censored data where you put the variable that's a sensor here and use the code for the sensor here. And you can also, I'm going to click run and show you, we're going to get the standard least squares output by default from the generalized regression. So I click run. So down here I get the standard least squares output. But I also get at the top this option to do penalized regression methods like the lasso, elastic net, ridge regression. So there's a lot of flexibility in this platform. From the standard least squares, again, I can get things like the profiler. I can get diagnostic plots really easily, multiple comparisons. I'll look at the profiler again. And so in this case, we were predicting household income by these three variables and all their interactions. And you can see confidence intervals in this case with the least squares regression. So I can see a mean confidence interval on the prediction. So for this particular value, so for, let's say, for an IQ of 100, where the population is 5.8 million, the 8th grade math score is 278, my household income prediction is 47,792, with a confidence interval from about 45,000 to about 50,500. That's a pretty wide confidence interval, but as I drag to a region where we had less data, like lower IQs, you can see that confidence interval gets much wider, and you can see this confidence interval here on what the prediction really should be is much wider. So we can see the areas of prediction where we don't have as much confidence in how accurate we're being. So I can see visually from this model that this is not a well-fitting model, that in fact I have a lot of uncertainty about these effects and a lot of uncertainty in my prediction. So the profiler is very valuable for understanding what your model is really telling you. Okay, let's hit up two more topics. We'll talk really quickly about some multivariate methods. So I'll go to Analyze and, well, let me open a new data set. Let's use this body measurements data set. These data are measurements on body measurements for 22 individuals. So we have their mass, the circumference of their forearm, their bicep, their chest, a bunch of measurements. So if I go to Analyze and down here to Multivariate Methods, I get some options for different multivariate methods. So I'll just start here with the top one with multivariate. I'll ask for all of these variables to be included, and this is going to give me correlations. I'll see multivariate and correlations. So this is how I very quickly get the correlations between these continuous variables, and I get a scatter plot matrix as well. Again, I can always hover my mouse in the bottom corner to resize plots. I can use the red triangle to find other options, like I can shade this ellipse, I can change the color. So this is looking at correlations. One other efficiency point that I'd like to make about JMP is, let's say I wanted to explore what are the correlations like only for the heaviest people, the people with a higher mass. So I want to just look at the correlations for the top part of the data and compare that to the correlations for the bottom part of the data. When I want to do these sort of drill down things where I'm changing the pot of data that I'm interested in, this is a time where I can use the red triangle and go down to that local data filter. So local data filter here, if I want to filter on mass and just look at the correlations for the high mass, I can click mass and add, and I can look at just maybe the top half. So this is just when the mass is between 75.896 and 94. So here I see now the scatter plot matrix and the correlations just for the top. You can see that now some of these correlations, the neck and head correlation, turned red because they're negative. So this is now a high negative correlation between neck and head just for the high mass individuals. For the low mass individuals, the neck and head correlation was positive and a little bit weaker. So I can use the local data filter from any platform to explore data further based on some other feature, some other variable in the data. And then let's look at clustering as well. I'll use the birth and death data set here. So this is, we have the countries of the world, or a number of 74 countries of the world. We have their birth rate and their death rate, and I also know what region they're in. So here I can go to analyze and clustering. So we looked at a little bit of multivariate methods, and now I'll look at clustering. We'll do hierarchical clustering. And I want to use birth and death to try to cluster countries together that have similar birth rates and death rates. So when I get this output, I see a scree plot on the bottom that sort of shows me where it suggests I break my clusters, and these little diamonds correspond to that. So that's telling me that there are 1, 2, 3, 4, 5, 6, 7, maybe 8, 9, I can't tell exactly where this is, clusters that are recommended. But if I want fewer clusters, I just want to look at a lot of clusters. Oh, there were 12 clusters. So maybe I just want 5 or 4 clusters. I can wiggle this guy around and bring it to the point of the clusters I want, and then I can go to the red triangle and I can, for example, color the clusters or mark the clusters. So if I color the clusters now, I'll see the 4 clusters I've selected in 4 different colors, and maybe I'll also choose mark clusters. And now if I go to Graph Builder and I drag country down into map shape, I can see the clusters on the map of the world. I can see that because I colored them, that went back into the data table, and now the data points are colored according to the clusters. So I can see that the birth and death rates are similar for all the blue. They're similar within the green, they're similar within the red, and within the orange. I can make this map prettier by doing things like adding a background map. So I right-click in the middle, select Graph, and select Background Map. Maybe I'll choose a detailed Earth map. I can drag this little hand on the top to zoom in a bit on my map. I can ask for other things from right-clicking as well. And so when I'm happy with this, I can click Done. Again, I can use the plus sign, the fat plus sign, to copy and paste this, or I can export this by going to File and Export. Okay, and the very last topic I want to cover today is a little bit of text summary. So for text summary and analysis, I'll use this pet survey data. This is fictional answers to the question, think about your cat or dog, what's the first thought that comes to mind? So what we have here is unstructured text data. There's a new icon on the side. Instead of having continuous or ordinal or nominal, we now have unstructured text data, so it kind of looks like a little paragraph on the side. And this type of data, or anything else that has text in it, so even if we had an ordinal or a nominal variable here, anything that's got character in it, I can use in the Text Explorer. So here I'll go to Analyze, I'll go to Text Explorer. This is the column I want, so I'll move it into the text columns, and I'll click OK. So I see how many terms are in all of these responses. I can see the most commonly occurring word was cat. It happened 55 times. Dogs happened 48 times, dog 46 times. I see phrases like video of the cat, so apparently a lot of people talked about cat videos in this data set. Sit in my lap, cat food, dog food, duck hunting, funny video. If there are phrases that I want to include in my analysis, so maybe I want everything that happened at least 4 times, so I'll highlight these, I right-click, and I add phrase. This will add them into the analysis. It'll put them over here on this side and include them in the analysis. Likewise, if I click on a word and I right-click and I select rows, this will select every row back in the data table where the word dogs appeared. Or I can select show text and just see all the lines where the word dogs appeared. So line 3 said my dogs are not allowed in the house when they're dirty. Line 6 said my dogs are so spoiled they will no longer eat dog food. So there's a lot I can do just by right-clicking on top of a term to show text or select rows. I can also add stop words if I don't want to include words in my analysis. But let's go to the red triangle and the very top option, Display Options, Show Word Cloud. This is where I get a word cloud. And there are, again, from the red triangle, options to make it prettier, so I could center it. I could apply arbitrary colors or click in the color to change the color. And I don't like that dogs, dog, and cat show up so large. I think I actually would like to remove them and see what the word cloud looks like without them. So again, if I right-click on a word, I can show the text where that occurs or show the rows, or I can add stop word to get it out of there. I can do the same thing here with cat, add stop word, with dog, add stop word. And now I see a little bit better what words sort of pop to the surface after I've taken out dog and cat. Maybe I'll take out cats also. Add stop word. Okay, so we covered a lot today. We talked a lot about the analyze menu. We talked about distribution for univariate statistics. We talked about fit y by x for one x and one y. Tabulate for making tables. Text Explorer for analyzing text, like making these word clouds. Fit model for anytime we have more than one x or more than one y, but also many deep things like mixed models are there. The generalized regression platform that allows you to use a penalized method like the lasso method. We talked a little bit down here in these specialized methods like multivariate methods. Multivariate is where you get correlations. We talked about clustering, and we used hierarchical clustering to get a cluster of countries based on birth and death rates. And now we've got just a couple minutes left, so I'd like to open it up for questions. Mia, if you'd like to let me know if there's anything people have been asking, and if you have a question, if you want to send it in the chat or Q&A.